Hello, here's our solutions for the 12.4 homework. So this is numbers 2, 9, 10, 13 through 16, 38, and 45. Okay, let's start with number 2. So we've got two vectors, 1, 1, negative 1, and b, which is 2, 4, 6. And we're going to take the cross product, a cross b. All right, so a cross b, we're going to start off with ijk, then put 1, 1, negative 1, then 2, 4, 6. I'm going to do it the initial way, not the shortcut that Jaden showed us last time. So we'll take I times the determinant of the matrix that's formed when we delete that row in that column. So we'll be left with 1, negative 1, 4, 6. Then the minus j, that's kind of the catch there, right? The signs alternate. Now delete that row and column. We're left with 1, negative 1, 2, and 6. And then we're going to go plus k, and we're going to delete that row and column. So that means we are left with 1, 1, 4, and 6. Okay, so we've got I times 6 plus 4 minus j times 6 plus 2 plus k times 6 minus 4. So our cross product is 10, negative 8, 2. And we're going to confirm, that's what the directions say, verify that it's orthogonal to both A and B. So if I take A dot, why don't we call this thing C? A dot C, that's 10 minus 8 minus 2, which is 0, so that checks out. Then let's do B dot C, and that is 20 minus 24. Nope, sorry, that's not right. 20 minus 32 plus 12, and so that also is 0. So it is orthogonal. So we confirm that, yep, the new vector, the cross product, is orthogonal to both of the originals. All right, let's go to 9. In 9, it says, find the vector not with determinants, but by using properties of cross products. So I cross j cross k. I cross j cross k. So we want to just use right-hand rule here, okay? So here is I, j, and k. I cross j, so fingers in the direction of I and curling towards j gives us k. And then k cross k is the 0 vector. That was one of our properties. A vector crossed with itself is the 0 vector. Next, 10. K cross I minus 2j. So k cross I minus 2j. Okay, so let's take this as k cross I minus k cross 2j, which is k cross I minus 2 times k cross j. So again, we're using properties, we're not using computation. So let's do k cross I. Fingers in the direction of k, and curling toward I gives us j. And then k cross j, fingers in the direction of k, and curling toward j gives us negative I. So that's minus 2 times negative I. So I get j plus 2i for my solution to that one. We could confirm it, of course, by actually doing the computation, but j plus 2i is the answer to that one. Okay, next problem. Let's have a look at 13. Okay, so 13 says, state whether each expression is meaningful. If not, explain why. If so, state whether it is a vector or a scalar. Okay, so part A dot B cross C. By whether it's meaningful or not, that really just means, like, is it defined? So A cross B cross C. This is a vector, and it is possible to dot a vector with a vector, and we get a scalar. So that is meaningful. Part B, A crossed with B dot C. Well, B dot C is a scalar, and you can't cross a scalar with a vector, so this is not meaningful. We'll just say NA. C, A cross B cross C. the cross product of two vectors is a vector, so A crossed with a vector is another vector. D. A dotted with B dot C. B dot C is a scalar, and you can't dot a vector with a scalar, so this is not applicable. E. A dot B crossed with, right away I know it's not meaningful because this is a scalar, and you can't cross a scalar with something else, so this is NA. In part F, A cross B, and then dotted with C cross D. This is meaningful, but it's going to be a scalar result because we're doing a vector dotted with a vector. Okay, hang on one second. Let me just, sorry for the pause here. I just wanted to look up my solutions that I have in my folder. There we go. Okay. Next up is 14. And we've got find the magnitude of U cross V and determine whether U cross V is directed into the page or out of the page. So we have a theorem that says U cross V is the magnitude of U times the magnitude of V times the sine of theta, where theta is the angle between the vectors. The magnitude of U is 4, the magnitude of V is 5, and sine of theta is root 2 over 2. So here we have 10 root 2 for our magnitude. And if we do the right-hand rule, U cross V, fingers in the direction of U, curling toward V, it is out of the page. 15. All right, so same deal. Magnitude of U is 12. Magnitude of V is 16. However, the angle between the vectors is not 120. If you put the vectors tail to tail like they should be, you'd see that the angle is 60 degrees. So we're going to take the sine of 60, which is root 3 over 2. 12 times 16 is, let's use a calculator. 192. So this is 96 root 3. That's the magnitude. And if you take U cross V, this is going to be into the page. Okay. 16. The figure shows a vector A in the xy plane and a vector B in the direction of K. Their lengths are 3 and 2. Find the magnitude of A cross B. Okay, using the same theorem above, because the angle between A and B is 90 degrees, that means sine of 90 is 1, so it's just the product of the magnitudes. So our answer there is 6. The magnitude is 6. That's part A. And then part B, it says, use the right-hand rule to decide whether the components of A cross B are positive, negative, or 0. So if we put our fingers in the direction of A and curl toward B, let me try and draw this for us. So pretend this is B, and A is doing this. The cross product is like going in that direction, kind of like that, right? It's going to be kind of going into the positive x but negative y. So the components are going to be a positive x coordinate, a negative y coordinate, and it's going to lie in the xy plane. So it's going to be 0 for the z coordinate. Okay, 38 and 45. Okay. 38. Use the scalar triple product to determine whether the points A, 1, 3, 2, B, 3, negative 1, 6, C, 5, 2, 0, and D, 3, 6, negative 4. So determine whether they lie in the same plane. Okay, so in order to do this, we're going to basically see, let's compute the volume of the parallelepiped that's bounded by these points and see if that volume is 0, then we know that they all do lie in the same plane. Okay, so let's compute the vector AB. 2, negative 4, 4. The vector AC, 4, negative 1, negative 2. And then the vector AD, 2, 3, negative 6. Okay, to find the scalar triple product, we're going to take the determinant of the matrix containing that matrix. Okay, so we're going to take 2 not I anymore, right? 2 times the determinant of -1, -2, 3, -6, minus -4 times 4, -2, 2, -6, plus 4 times 4, -1, 2, 3. So we have 2 times 6 plus 6 plus 4 times -24 plus 4 plus 4 times 12 plus 2. So 2 times 12 plus 4 times -20. Yep, and then plus 4 times 14. 24 minus 80 plus 56, and that is 0. So, because the volume is 0, so that's the volume of the parallel pipe head, so these are coplanar points. All right, and then finally, let's do 45. Okay, so let P be a point not on a line L that passes through the points Q and R. Here's Q, here's R, and here's the point P. Okay. Show that the distance D from the point P to the line L is that. Okay, so we are interested in this distance right here. That's D. And we're supposed to show that D equals the magnitude of A cross B over the magnitude of A. Okay, so A is QR. So that's vector A. And then vector B is QP. So that's this vector right here. Okay, so let's see. How can we proceed here? All right, if this is the angle between the two vectors A and B, then D is equal to the magnitude of B times the sine of theta. Okay, that's D, right? That's the distance that we have there that we're trying to find. But we know that the magnitude of A cross B equals the magnitude of A times the magnitude of B times the sine of theta. And if you divide both sides of this by the magnitude of A, this gives us what we need. That the distance is, see, this is the distance just from geometry, and therefore this is also the distance. So we've proved our theorem. So part B says use the formula in part A to find the distance from the point P to the line. Okay, so all we have to do is this. We have to say, let's figure out what QR is. All right, so QR is -1, -2, -1, and that is vector B. Oh no, sorry, that's vector A. And then QP is our other vector. So we'll start at P and go to Q. So we're going to take, start at Q and go to P. So we'll take P minus Q, which is the vector 1, 5, 7. Okay. P minus Q. Yep. Okay, great. So the magnitude of the cross product is, we have to compute a cross product. This time I'm going to use Jayden's shortcut that we discovered. -2k minus 5i minus 7j. So we did these as a sum. We're going to do these as a difference. So plus 5k plus j plus 14i. What do we have here then? 9i minus 6j plus 3k. Okay. Oh, that does not correspond with what I have in my previous notes. Let me check what went wrong here. -1, -2, -1. Oh, okay, there's a problem here with my vector QP. All right. P lies off. So QP 1, -5. Ah, my mistake. A -7. This should be a -5 and a -7. Okay, so this should be a +5i and a +7j. That doesn't get affected. That doesn't get affected. And then this should turn into a minus. Okay. So let's revise. Do we still have a 9i? So -9i. And then plus 8j. And then plus 3k. It's still not matching with what I got before. What's going on? Let's go to the calculator and check it. Okay, 1, -5, -7. So magnitude is product of A and B. Okay, so why am I not getting 7 for the last component? Sorry to waste your time on the video here with this. Oh, because I didn't change this to a -5 as well. Okay, well, just like you, I make mistakes. So it should be a minus. Okay, so that's going to be -7. Okay, so if we found the magnitude of that, it would be the square root of 81 plus 64 plus 49, which gives us square root of 194. And then our denominator is the magnitude of A, which is root 1 plus 4 plus 1, so root 6, and we can just leave it at that. That is our answer. Okay, sorry about the mistake on the last one there. Hopefully that's still helpful to you.